Hi students, how are you all? So I am going to start again the crystal atom video 2. How was the video number 1? It's okay. I know the sound was little less. I try to compensate on this video. This content was very good, isn't it? I have seen the views. Okay. So this is the video 2 regarding the atom. So this is the again the continuation of the video 1. So for that one, I'll just briefly explain what we have learned in the video number 1. First we have learned about the J.J. Thomson's plum pudding method of atom. Then we have studied about the Rutherford's nuclear method of atom. Then we have studied about the Jaeger-Madsen scattering experiment. Understood? No, that time I already told that next class we will be doing some numericals. Clear, no? So today we will be doing some numericals. This is very important for the JEE exam as well as the NEET exams. In today this lesson I will teach you 4 numericals. Out of that one, 2 numericals are going to come. That is sure. So let's start for that one. So see, I'll just this is the exactly one of the NEET exam. So I'll read the question paper, then answer is also given, then we'll see what is the findings. So I'll just read the question. If scattering alpha particles are 56, this one is 56, for 90-degree angle, then this will be at 60-degree angle. I know this one is grammatically it is not correct. Only technically it is correct. So we are going to correct it. I'll just technically as well as grammatically. So this one you can just tell in the other way. If alpha particle at 90 degrees scattered 56 numbers. So at 60 degree, how much will be? How much number of alpha particle will be turned? That is a question. So we'll just write it this one. So this one is the n. This one is the theta 1. So this one is the theta 2. So they are asking for the n2 is how much? Clear, no? This one is the question. So I'll just explain the graph, the previous graph what we have learned is. From here we have taken that one. This one is the angle. This one is the number of particles scattered. So it is 180 degree maximum. This is 10 to the power of 7. So graph is going to come like this. Clear, no? So these are the points. These are the points. These are the points. This side. There is an equation is there. N is equal to, N is the, what is the number of alpha particles scattered. So it is the N. N is equal to constant K divided by sine raised to 4 theta by 2. So we'll apply on this one. N1 will be sine raised to 4 theta 1 by 2. N2 will be sine raised to 4 theta 2 by 2. So we want it N2 also here. So we'll write it there. N2 by N1 is equal to K. Both the K's will get cancelled. So N1 is in sine raised to theta 1 by 2 divided by sine raised to theta by 2. Clear, no? Because this is sine theta 1, it is going to go up. The theta 2, it is going to come down because it is inversely proportional. Clear, no? Sure? Okay. So this one is the, so I am just writing it again. So N2 is equal to N1 into sine raised to theta 1 by 2 divided by sine raised to theta by 2. I'll just put the values there. N1 is how much? 56. 56. So this one is 56. Okay, so I'm just putting the value here, 56 into sine raised to theta 1 by 2. Theta 1 is how much? 90 degree. 90 by 2 raised to, this one is always 4 is there. 4 raised to 4 raised to 4. Okay, because raised to 4. Sine raised to 4, 90 by 2 divided by sine raised to 4, 60 by 2. Clear, no? I'm just again writing is equal to 56 into sine raised to 4, 45 divided by sine raised to 4, 30. Okay, now if you know the value of sine 45 or if you know the value of sine 30, it is very easy. So the value of sine 45, sine 30, I'll just explain here. Sine 0 is equal to 0. Sine 30 is equal to 1 by 2. Sine 45 is equal to root 2 by 2. Sine 60 is equal to root 3 by 2. Sine 90 is equal to root 4 by 2 is equal to 1. So just see this one, 0, then again sine 30 is 2, 2, 2, 2 is continuing. Then 1, root 2, root 3, root 4. So very simple, no? To memorize this one, sine 0, sorry, this one is 0. Sine 0 is 0. Sine 30 is 1 by 2. Sine 45 is root 2 by 2. Sine 60 is root 3 by 2. Sine 90 is root 4 by 2, that means 1. Very easy. So I will put the values here now. Is equal to 56 into sine 45 is root 2 by 2. Root 2 by 2 raised to 4 divided by sine 30. Sine 30 is 1 by 2 raised to 4. Clear, no? So we'll write it again here. 56 into root 2 by 2 raised to 4. That means 4 divided by 60. So this one I am putting back into 16 by 1. Clear, no? So 1 raised to 4 is 1. 2 raised to 4 is 60. 1 raised to 4 is 1. 2 raised to 4 is 60. So root 2 raised to 4 is 4. 2 raised to 4 is 16. So 56 again it is there. So cancel, cancel. So it is going to become 56 into 4. 56 into 4 is how much? 102. It's a 4. 2 remainder 224. So answer will be 224. Clear? So N2 is equal to, this one is N2. Very easy, no? So NEET exam, they will give you different values. Sometimes they will give you N1 is 56, theta 1 is different one, or theta 2 is different. So this question is going to come 100%. So it is very easy. So learn it. I am going to rub it. So you can just write it there. I'm going to rub. Okay, can I rub it? Okay. Now we will start the theory again for the atom. Okay. So, alpha particle trajectory. Yeah. Alpha particle trajectory. This one trajectory. Okay. What do you mean by that name trajectory? Yeah. What is meant by trajectory? It is the simple English word. It is called as the path followed by a projectile. It is the path followed by a projectile. Okay, what do you mean by a projectile? Projectile means, for example, projectile is somebody is throwing a stone, somebody shooting. That means a thing started with a kinetic energy, and it is started with a kinetic energy, it is moving on its kinetic energy, and it is going to rest somewhere. It is called a projectiles. So same way, the alpha particle trajectory. So we'll explain this one. In this parameter, we are going to learn impact parameter. Impact parameter. Notation is B. B. So very important one, impact parameter B. So we'll go for that one. I'll just draw that diagram. Okay, this one is the nucleus. So we can say it is the, assuming it is the gold nucleus. Gold nucleus. Okay, so this one is the alpha particle, it is coming here. Okay, this one is the alpha particle. We know that one. How many charge? 2 positive charge. It is the helium. Helium 2 raised to 4. We already learned that one. There is no electron there. Only positive charge are there. This is moving like this. This is moving like this. This is moving like this. And I'm just writing, if this one is coming like this is going to come back. Because this one is also a positive charge here. So this one is coming here. After that, this one is going to come back. Okay, I'll just draw another line. This one is another alpha particle. It is coming here. It is going to go like this. Another alpha particle is there. It is going to go like this. Another alpha particle is there. It is going to go straight. Clear, no? These all alpha particles. So the impact parameter D, I can say for this I am just removing the remaining this one. I am taking only this one. Okay. So this one is the impact parameter B. Impact parameter B. This one is the what is that? This one is the perpendicular distance. This one is the perpendicular distance from the center of the nucleus to the initial velocity vector of the alpha particle. So, impact parameter we can write impact parameter. Impact parameter. It is the perpendicular distance. Everybody understood how it is writing perpendicular? It is the perpendicular distance. It is the perpendicular distance from the center of nucleus to the initial velocity vector of the alpha particle. Clear, no? So, this one is from the center to the initial velocity vector, because there are two parts. That's why I completed. This one is the initial, this one is the afterwards. Clear? So, initial velocity vector. Here is another vector is going. So, this one is will be the initial velocity vector. So, this one is called as initial velocity. This initial and final we will study after this portion. We will study little detail of this one. So, I just read it again. B is the impact parameter. It is the perpendicular distance from the center of the nucleus to the initial velocity vector of a alpha particle. B. Clear? So if you want definition, please write it. Once you finish, I'll rub it out, because I want to write something also here. Okay, now you tell me, if this B is equal to 0, B is equal to 0. If B is equal to 0 means this line is going and it is coming back. So, this theta is equal to how much? This is a 180 degree. Clear, no? If B is equal to 0, theta is become 180 degree. So, this one is the NEET question. If the impact parameter B is equal to 0, this angle is how much? It is 180 degree. So, they never ask for 180 degree. They will ask this one 180 means how much? It is a degree. So, another method is we can say it is a radiant. It is a radiant angle also we can write it there. So, how we can convert degree into radiant? Can we just, I will just draw how we can go for degree into radian. So, this angle degree radian. Okay. This is as per the degree how much? 180 degree. This angle how much? Pi. So, this angle how much? 180 degree. So, this angle is again as per the radian, it is pi. So, in a circle, how many angle, the total angle is as per the degree? 180 plus 180 is equal to 360. In a radian circle, how much? Pi plus pi is equal to 2 pi. Clear, no? So, radian, it is in pi, degree is equal to in angle 360. How will convert 180 to radian? So, it is very easy. To convert a radian is equal to degree into, see, if you want to convert radian, always pi will be on the top, pi by 180. So, we will just convert radian is equal to degree into pi by 180, degree is 180. So, 180 will cancel. So, radian is how much now? It is pi. Everybody clear? So pi will convert into radian and see. Radian, so degree. Oh, we're here. Oh, here are. Radian is equal to degree into pi by 180. See, if radian, pi should be on the top. So degree is equal to radian into 180 divided by pi. Clear, no? If the radian, degree into pi by 180. So degree is here 180 degree. So 180 plus 180, pi is going to come. So degree I am going to convert radian. How much is there? Radian is pi. Pi into this one is pi. So pi and pi, so 180. Clear, no? So 180, how we can convert radian? So the question will be, normally the question will be like this. If impact parameter b is equal to 0, how much will be the angle of deviation? Theta. Normally they will give pi, 2 pi, pi by 2, pi by 4. So how much will be the answer? Answer will be pi. So very important. Another JEE question. Normally they asking like this. Clear, no? How to convert radian to degree to radian. So it is very simple. Then alpha particle trajectory. Clear, no? So projectile impact parameters. What is the definition of the impact parameter? It is the perpendicular distance from the center of the nucleus, to the initial velocity vector of the alpha particle. Clear? Okay. So just you can write it there. Then I'll remove it. I'll go for the next. Can I remove? Okay, let's go. Okay, next will be the alpha. Trajectory model is already finished. Now we'll go for the distance to closest approach. Distance to closest approach. Distance to closest approach. This one is denoted by d. So we will be very sure that after this class you don't be confused about the distance of closest approach as well as the impact parameters. I will make sure that you will be get clear. Okay, yeah. So distance of the closest approach. So we just go again draw the diagram. The alpha particle is coming here. Again the nucleus is going to come here. This is the nucleus. Clear? Okay. So I'm just putting there alpha particle plus plus. This is also plus plus. Okay. Now this alpha particle is coming here. It is coming here. It is coming here. This is coming here. This is coming with what? I already told alpha particle is like a projectile. So it is coming with a kinetic energy. So it is coming with a kinetic energy. So I told you this one is the initial kinetic energy. Kinetic energy initial. So it is coming here. This nucleus is having a positive charge. So it is having a potential energy. It is not a normal potential energy. Normal potential energy, how, what is the equation? Potential energy is equal to mgh. So this one is not a normal potential energy. It is called electric potential energy. It is, this nucleus is having a energy is called electric potential energy. Electric potential energy. Normally it is denoted by U. So this alpha particle is coming here, coming here, coming here, coming here. This is having a potential energy. So up to some time, the distance of close approach reaches, this kinetic energy become potential energy. So this is now up to here, it is go here, then it is started stable. It is going to become stay there. So in this point, it is become potential energy. So electric potential, the alpha particle kinetic energy is transferred to the potential energy. So it will not be going further. So it is going to go backwards. So again, if you going backwards, this potential energy is transferred to the kinetic energy. Clear, no? So I am just writing the if it is coming like this, it is going like this. Clear, no? So what is this one? B. Impact parameter. Impact parameter. Then what is the distance of closest approach? Is this this distance denoted by D. So this is the distance. This is the distance between the minimum distance. This is the minimum distance. So we can say this is the D. This is the D. So again, if it is going like this one is the D. So this is the minimum distance from the nucleus, from the center of the nucleus. Very important, from the center of the nucleus. It is the minimum distance from the center of the nucleus to the point of deviation. There, the kinetic energy is equal to potential energy. Clear, no? So what is that one? It is the minimum distance from the center of the nucleus to the alpha particle, which the kinetic energy converted to potential energy, or kinetic energy is equal to potential energy. So I'll just write it there. The distance of closest approach. It is the minimum distance from the center of the nucleus. It is the minimum distance from the center of the nucleus to the alpha particle, where kinetic energy E become electric potential energy. Now everybody clear what is the distance of closest approach? It is the minimum distance from the center of the nucleus to the alpha particle, where the kinetic energy become potential energy, or kinetic energy equal to a potential energy. That is kinetic energy equal to, that is more better. Equal to electric potential energy. So we can write it down, the definition. I am going to remove. I need to do something else also. Okay. Okay. So I'll just draw little this one. Yeah. This one is the energy initial. This is the energy final. Clear, no? So we know that energy initial is equal to energy final, because law of conservation of energy. Law of conservation of energy. Yeah, what is law of conservation of energy? Energy cannot be destroyed. It can be transferred from one form to the another form. That is called conservation of energy. So, law of conservation of energy, EI is equal to EF. What is EI? This is a kinetic energy. What is EF? Electrical potential energy. Electric potential energy. U. Clear now? So, what is the potential energy U equation? It is called as K Q1 Q2 by D. Clear now? So, electrical potential energy is equal to K, it is a constant. Q1, it is the energy of the alpha particle. Q2, energy of the nucleus. D is the distance of closest approach. So, I am just writing there. So, kinetic energy is equal to K Q1 Q2 by D. Okay. So, I will just write it what is Q. K is equal to 1 by 4 pi epsilon 0 is equal to 9.0 into 10 raised to 9 Newton meter square per Coulomb square. Okay. Q1, we know that one. What is the energy of the alpha particle? It is 2E. What is energy of Q2 nucleus? Z into E. So all parameters are now there. We'll just put it here. Is equal to 1 by 4 pi epsilon 0 into 2E into ZE 2E ZE into D. Clear now? We'll just write it. Kinetic energy is equal to 2 E square Z divided by 4 pi epsilon 0 D. See, or we can say D is equal to, kinetic energy is equal to D will go down. Okay. So I just remove this one. Okay, you can, if you want, you can write it there. I'll just remove this one. Okay, so we know that one, the kinetic energy is equal to, 2 E square Z divided by 4 pi epsilon 0 into D. So I am just writing D is equal to, this is going to go 2 Z square epsilon Z 4 pi epsilon 0 kinetic energy. This is very important. Distance of closest approach D is equal to 2. This is 2 and this one is Z. So 2 E square Z 4 pi epsilon 0 kinetic energy. So we know that one 4 pi epsilon 0 is equal to 9 into 10 raised to 9. E, we know that one. Z is equal to, what is Z? Atomic number. We know that one. Z is equal to atomic number. So we can take it this equation. We'll do a numerical on this one. This is the second numerical on this one. Okay. This numerical, normally it is going to come in the NEET exam. Clear? If you can take it down, go for the numericals. an alpha particle of 5 mega electron volt strike with nucleus of uranium at stationary at a scattering angle of 180 degree. The nearest distance up to which the alpha particle reaches the nucleus. Okay, so we'll just read the things. An alpha particle of 5 mega electron volt, 5 megavolt, so that is the kinetic energy, strikes with the nucleus of uranium. Uranium is how much? Uranium Z is how much? 92. At a stationary, at a scattering angle of 180 degree. This scattering angle they are given for making you trouble. So it is not at all in use. The nearest distance up to which alpha particle reaches the nucleus. So that is the distance of nearest approach. D is equal to, we know the equation, 2E Z right, 2E square Z divided by 4 pi epsilon 0 into kinetic energy. Okay, so we'll just do everything here. 1 by 4 pi epsilon 0 is equal to 9.0 into 10 raised to 9 Newton meter square per coulomb square. So kinetic energy is 5 mega electron. So is equal to 5 into 10 raised to 6 electron. Z is equal to 92. Okay. Again, electron is 1.6 into 10 raised to minus 90 coulombs. Clear now? So we'll apply here 2 into this E square into Z is 92 divided by into 9.0 into 10 raised to 9. This one is here, divided by kinetic energy is equal to 5 into 10 raised to 6 into E. So this E get cancelled. So answer will be 2 into 1.6 into 10 raised to minus 90 into 92 into 9 into 10 raised to 9 divided by 5 into 10 raised to 6. Clear, no? So we'll just go once again. 2 is equal to 2 into 1.6 is how much? 3.2 into 92 into 9 divided by 5 into 10 raised to minus 90 plus 9 minus 6. Clear, no? So 3.2, 92 into 9. So how much you are going to get? You can just go to get the 530. You can just calculate 530. And this one is minus 90 plus 9 minus 10 minus 60 into 10 raised to minus 60. That is meter. Clear, no? So I'm just converting We know that one Fermi is equal to 1 Fermi is equal to 10 raised to minus 5 meters. So I'm just converting this one into 53 into 10 raised to minus 15 meter is equal to 53 Fermi. Clear now? So now our answer is, what is alpha particle nearest distance? It is d is equal to d, distance of nearest approach, is equal to 53 Fermi. Clear everybody, friends? This one is going to, if you want to see this one, you want to convert this one to meter. If you want to convert this one to centimeter, 53 into 10 raised to minus 30 centimeters, or 5.3 into 10 raised to 12 centimeters. So we can say it is 10 raised to minus 12 centimeters. So that is the best one. So either this can be 53 Fermi or 5.3 into 10 raised to minus 2 centimeters. Sometimes they will ask you, the NEET questions, they will ask you only 10 raised to minus 12 centimeters. So exam 53 Fermi. So both are same. I just explain once again. An alpha particle of 5 megavolt mega electron volts, that is the kinetic energy. We know the kinetic energy. With a uranium, Z is equal to 92, stationary scatter particle 180 degree, that is nothing. So they want the distance of closest approach. D is equal to 2 Z square, 2 E square Z 4 pi epsilon 0 into kinetic energy. 2 E square, this one E is going to get cancelled. So only E is now remaining, 92 and 9.9 into 10 raised to 9. This is a 1 by 4 pi epsilon 0. So again we are calculating. So 10 raised to minus 19 plus 9 minus 6. So 10 raised to minus 60. 530 into 10 raised to minus 16 meters. So 53 into 10 raised to minus 5 meters. So it is 53 Fermi. So again 5.3 into 10 raised to minus 2 centimeters. Clear, my friends? So this is a question. So it is very important. Study well and good luck for your exams. So we'll see again with the next physics chapters, and we'll keep on posting you and study well. Thank you very much.